Well, hello and welcome to this mini session on climate change mitigation and the role of green building and retrofit. This presentation is brought to you by Dr. Azadina Jahan from Vancouver, British Columbia. Welcome again. So today we're going to talk about decarbonization of the built environment. This session will talk about 4 key points. We'll state the problem of the built environment. We'll review green building solutions, retrofit features, and summarize that in some solutions to drive towards sustainability and resilience. First of all, what is the problem that we are facing in the built environment? High costs, upfront costs for green building construction, shortage of labor, disparity in the codes and standards and the policies depending on the jurisdiction. BC, Alberta, Ontario, Quebec, each province has a different policy and standard. And lastly, scarce resource, scarce material, and information about the embodied carbon. When you're purchasing building materials, you often don't have what we call an environmental product declaration, which actually states the GHGs that product has or is contributing to. All of those challenges are opportunities for the green practices, and we're going to talk about those at a high level today, and with an opportunity for you to dive in more in depth in all of them. But before we get started, I would like to share 3 resources here. I'm going to give you a minute to scan the QR codes, giving you case studies for retrofitting, green building strategy for the Government of Canada, and lastly, guidelines for retrofit, commercial and other type of buildings. And before we get starting throughout this session, I will have some time to reflect, to pause and reflect. First reflection that we're going to do is to look at these 2 images and then select in which building you would like to spend most of your day in. This is an office institutional building, so which one would you select based on the 2 images? In terms of learning outcome, like I said, 4 points. The first one is understanding the impact on global greenhouse gas emissions that the built environment has. Overall, it's about 38 to 40% depending on the location, and that's a contribution or emission resulting from the building in general, operation, construction, and so on, and transition into the building. But more importantly, building or the built environment uses a lot of resources for construction material, the water. And so how can we achieve climate change mitigation and carbon net zero by 2050? Solution is green building practices for new building, green building practices to retrofit and upgrade an existing building stock. 2 important definitions for the built environment when we talk about carbon. We always mention GHGs, carbon CO2 equivalent. For the built environment, those 2 features or characteristics are identified as 1, the embodied carbon, which is the carbon resulting from all the processes from extraction or harvesting to the construction and the handout. The embodied carbon is locked into the building and it contributes to the carbon footprint. The second carbon that the built environment has is the operational carbon that results from heating, cooling, lighting, and operation of equipment, and so on and so forth. The addition of the operational carbon and the embodied carbon equates to the total carbon footprint of a building. So when we talk about footprint, it's the overall embodied carbon, primarily from the construction and pre-construction materials, embodied carbon, and the operational is the efficiency in usage of the building. In Canada, when you look at the stats from Natural Resource Canada and NRCan, the built environment contributes up to 30%, a third overall, and it's 3rd place behind oil and gas sector and the transportation sector. Going back to reflections, the 2 pictures that I showed you actually were 1 building. is the Forest Science Center at the University of British Columbia in Vancouver. So whichever picture you have chosen, you are using the same building. What behind the decision is slightly different, and we'll have another reflection later on. So when it comes down to green building practices, what are the foundations? What are the basics? The basics are around 4 points, 3 or 4 points. For a new building, the foundations are about designing, constructing, and operating with the maximum efficiency and the minimum impact to the environment. What does that mean? What does it translate into when you want to design a new building? Is it the integration of those concepts at the beginning in order to minimize carbon emissions and waste and optimize energy efficiency for the usage of lighting, heating, cooling, and so on? That all is integrated. Enhancing the indoor environment quality, the air, and the comfort level, and lastly, conserving water primarily. And water is often put on the side, but it's also part of the whole UN sustainable goals in general, how to conserve and use less water, given that it's in some areas of the continent, it's quite sparse. So what a building in the future, sustainable building in the future will look like, well, that's not too futuristic, is a building that has a zero carbon footprint. Carbon footprint through the embodied carbon use of mass timber, use of solar for energy efficiency, for heating and cooling and so on, and the green roof to add into the features. But the key principle of green practices, green sustainable construction is to use it at day one and the design when you start conceiving your conceptualizing the project and building. Back to reflections. So in this case, I give you images of 2 buildings. These are 2 different buildings. One is a mass timber building, and the other one is a concrete building. And from these 2 pictures, I'd like you to select in which building would you like to spend most of your time, the mass timber or the concrete building, just based on the picture. Now I'm going to tell you, if you were to design the mass timber building, it would cost you $450 a square foot. The concrete will cost you a bit less, $350 a square foot. You still stick to your first choice of either one. And then lastly, I'll tell you that the mass timber building will have zero carbon footprint. It's carbon neutral. And the concrete building will have 8 tons of CO2 emissions per year. You still stick with your choice. Reflect on that for a minute. Now let's talk a bit about retrofit existing building. Now, this is significant because of the building stock that existing buildings have been built to prior standards where green practices were not in place. Before we do that, let's reflect. Which of the 2 buildings would you select? Left or right? Think about that for a minute. Now, what I said, one of the significance of the retrofit is the fact that 65% only of the residential building have been built prior to 2000, prior to implementation and integration of 4 practices of green sustainable practices. 16% were built between 2000 and 2010, and 19% were built between 2010 and 2020 or 2025 nowadays. Now, why these dates? For example, in British Columbia, the STEP code and energy code was implemented around 2010, 2011, meaning that all practices on new buildings have a feature of sustainability. Not all, but at least it's more forward. Whereas in Alberta, energy code was implemented or put in place in 2015, 2016. Again, those policy changes. But overall, 64% of the building stock in Canada predates 2000, which means features that are needing upgrade and update. So building stock is large. The opportunity to reduce GHGs when you retrofit the building is tremendous. at least 30% of GHG reductions by retrofitting the building envelope, the windows, the roof, the energy system, and so on. So, and depending on the retrofit that is done, can reach up to 50 or 60% of reductions of GHG and making the existing building almost carbon neutral. To the activity that I've shown you earlier, it is actually the same building. It's the University of Calgary McKinney Library, which was retrofitted 5-6 years ago with a retrofit that's now saving the university 80% in energy consumption alone. In addition to that, the building is carbon zero or carbon neutral and LEED platinum. So a retrofit to the green sustainable practices of a new build. Of course, when you're retrofitting, it's always going to be dependent on the state of the building you're retrofitting. And I used on purpose a building that's almost due for demolition. One thing that's not always highlighted is by retrofitting an existing building, you're not demolishing, you're not creating more embodied, you're using an existing and then enhancing the embodied carbon, because remember, the embodied carbon is locked in the existing infrastructure. So that's one thing to remember, retrofit versus demolition. Demolition, of course, from a construction perspective, is always cheaper, right? And that comes with a consequence. When it comes down to retrofit, two key features of any building or infrastructure needs to be addressed. One is the energy system, controlling or handling the cooling, the heating, the lighting, the hot water, and so on. That's often one aspect of retrofit, and it could be tremendous and expensive and costly. Think about retrofitting a house, changing the furnace to a heat pump. The second one is often neglected, depending on the age of the building, is the building skin or building envelope. Doing one with the other, would be dependent on, again, the state of the building. The building skin energy retrofit system is primarily to minimize heat loss and heat gains depending on the season, and that's also to address climate change mitigation. Primarily or fundamentally, retrofit revolves around 6 key principles: energy efficiency, lowering carbon, climate resiliency, integration of smart technology, smart grid, adopting of health and safety for the environment and for the building itself, and lastly, affordability. Remember, we talked about cost being a barrier for green practices. It has always to be encompassing any projects that we do. So to summarize, I would like you also to think about the building you spend most of your time in, your office or your home, and rank or rate its energy efficiency by going to menti.com, use the code 3864-7769, or simply scan the QR code if you had enough time to scan it. So in order to drive the sustainable practices for either retrofit or new construction, we always have to comply with standards. I'm sure mentioning the discrepancy or the variance between jurisdictions. Green building standards different in BC with the BC code. Alberta has its own BC code, and those have to always be compliant. Safety, of course, when you're doing remediation or retrofit, always faced with an existing infrastructure that may have hazardous material, asbestos. So always have a strategy, and these are key important features of the project. And lastly, energy modeling or analysis and validation, pre-retrofit and post-retrofit. Those are key considerations to put in place to monitor the results of the building retrofit. So to summarize, we talked about fairly quickly highlights of 5 or 6 key features of new buildings and retrofit in order to address and achieve carbon neutrality by 2050, and hopefully mitigate the climate change issues that we are faced on a daily basis, winter or summer. Thank you for listening. Hope you had a good time. And for further questions, feel free, or feedback, feel free to email me directly using the QR code scanning here. Thank you.